Hey everybody, today we are looking at compositions of transformations. All compositions of transformations mean is that we are doing one transformation followed by another. A specific type of composition is a glide reflection. The glide means we're going to translate first, then the reflection means we'll reflect over across some line. All right, anytime we are composing more than one rigid motion, meaning I'm doing multiple transformations that are all rigid motions, the final result is a rigid motion, because if none of them change size or shape, then the final shape will be the same size and shape as the original. All right, compositions of rigid motions are going to be expressed as one transformation multiplied by another, or written out in terms of we are going to do this and then this and then this. So for example, if we're looking at it in transformation notation, if I look at this set here, this is going to say, all right, I'm going to do my transformations to triangle ABC. So I'm going to reflect triangle ABC over the x-axis. And this open circle right here means composition. So then it's going to be followed by a translation of triangle ABC over the vector of -2, 5. You are going to see this open circle again when we start doing compositions of functions. We'll do like f of g of x. So that is something that, just so you know, that you will continue seeing throughout your math courses. All right, the next thing is when we do multiple transformations, we can do multiple primes. So if I look at this transformation and if I reflect first, well, when I reflect, that's going to be over A prime, B prime, C prime. And then when I translate, my final image will be double prime. Okay? All right. So let's take a look at what that looks like. So I'm going to start with this triangle by reflecting it across the line and then translating it along my vector B. So again, we're going to sketch here about the same side. So this is going to be B prime here, perpendicular to the line, that's important. And here's A prime. And then about the same distance here, and C prime. So this is my A prime, B prime, C prime. All right, and then from here, we're going to translate along the vector. So what I'm going to do is I am going to trace on top of my vector here. All right, and then I'm going to move it here. So that way, this point here is going to be B double prime. And then I'm going to move my vector. And again, I know you guys can't do this, but you're just doing the best you can over here. And this is going to be C prime, double prime. And then I'm going to move my vector over here to A. And then this point here will be A double prime. Let me get that out of where the triangle will be. So then this is my final triangle. And it is important that we do want to shade our final image here. All right, if you have any questions about that, please write it down. Again, at this point, we are sketching. We are not expecting perfection. Okay, only perfect we expect is on a graph. So the next thing that I can do, particularly with translations, is that I can write the translations as one transformation. So if I'm doing multiple translations, okay, if I'm going to take my figure and I'm going to go 2 to the left, or 2 to the right and 2 down, but then I'm going to go 1 to the right and 1 down. Well, basically what I'm doing here is I'm going 2 to the right and 1 more to the right, which means I'm going a total of 3 to the right. So it's a positive 3. -2 down, -1 down, so I'm going down a total of 3. So you're just basically going to add the two vectors together to get your final translation. So if we look here, -4 plus -2 is going to give me -6. 0 plus 5 is 5. So my overall translation vector is just the sum of the two vectors. All right. Again, any questions on that, go ahead and write it down. And the next thing we're going to look at is what happens when we have multiple reflections. So anytime I'm reflecting over parallel lines, okay, my figure is going to flip back and forth from a reflection to just a translation. Because if I look here, C just slides over to C prime. A slides all the way over to A double prime, B slides all the way over to B double prime. All right, it's like this one in the middle here didn't really happen. All right, so that is kind of where we're looking. So notice when we're looking here, all these distances are going to be double the width of here. And we're going to talk about how we find those lines here in just a second. If I reflect over lines that intersect, like these two do, the final transformation is going to be a rotation. So if I reflect twice, I essentially rotate. Now, the degree that I rotate is going to be double whatever this angle is. So like if this is 30 degrees, and it's more than that, but we're just making up a number, then from here to here would be 60 degrees. Because I've got to go this piece and this piece as well. So your angle of rotation here is always double what this angle is. All right? So let's take a look at actually doing multiple transformations. So we're going to start with triangle RST, which is going to have the coordinates 1, 2. S is going to be at 1, 4. T is going to be at negative 3, 4. And I'm going to start by rotating 90 degrees about the origin, and then we're going to reflect it across the y-axis. So first things first, when we rotate 90, remember that my rule for a 90-degree rotation is negative yx. So I'm going to start by doing that one first. All right? So when we look here, my point R, which is at 1, 2, is going to go to R prime, which bring the y forward, make it negative, and take the x back. All right, S is at 1, 4. So S prime, we're going to bring the y forward, make it negative, and send the x back. And then we have T is at negative 3, 4. So T prime is going to be negative 4, negative 3. All right, so let's graph that first. All right, so we're going to do, and I'm going to graph all this one in blue. Oh no, I'm not going to use blue because the original image here is blue. So let's just use black. All right, so we're going to go negative 2, 1. This is my R prime. Now, we always want to label our points, okay? If you have a letter on your points on the original or you're given coordinates with a letter, that means you need to be putting letters on your graph, okay? That will help you keep track of everything, and if we ask you to graph things, it'll keep you from getting things marked wrong. All right, so here's my triangle RST. All right, now, that's not my final figure because we have one more transformation. We are then going to reflect this across the y-axis. So my T prime, or let's start with R. My R prime, and we're just going to kind of copy what's up here for just a quick second. S prime is at negative 4, 1. T prime is at negative 4, negative 3. All right, remember my rule for reflection across the y is the only thing that changes is the x sign. All right, so when we're here at R prime, we're 2 away, we're going to go 2 this way. This is R double prime. All right, so R double prime is at 2, 1. S double prime is at 4, 1. And T double prime is at 4, negative 3. Remember, we're not changing how far up and down we're going. We're only changing how far left and right we're going. So then this is my final figure. And again, we are going to shade that in. It's especially important when you're doing multiple transformations that you are shading your final figure. All right. So when you have more space on your paper, you could have just said, all right, you've got your R prime, and then we could have just done another arrow over here, written the rule up here, and gotten R double prime, and did it all in one line. You don't have to do a separate set for each transformation. If you have multiple transformations, you're just going to do, okay, you've got R, it's going to go to R double, or R prime, which is going to go to R double prime, which might go to R triple prime. All right, so you can write them all in one line. I just like to write whatever the rule is above it. And that way it helps keep me on track. And you can see kind of where you went wrong when you make your notations like this and when you write things out like this. All right, let's do this one here. Okay, we're looking at, we have triangle ABC is essentially translated over to A prime, B prime, C prime. And I want to find the lines of reflection that are going to give me this. So what I'm going to do is I'm going to start by drawing, oops, I did that on the wrong one. I'm going to start by drawing a line that connects A and A prime here to here. And I want to essentially eyeball, and we're going to do the best we can, the midpoint of that segment. Okay? Then I want to eyeball the midpoint of the segment over here and the midpoint of the segment on this side. So I'm essentially cutting from A to A prime into 4 equal pieces. And then our lines are going to be perpendicular through these midpoints, the outer midpoints. So what'll happen is when I reflect this, this will go this way, and then it flips back. So you're going to draw the segment, find the midpoint, and then find the midpoint of each half, and draw the perpendicular lines through those. This one's not very perpendicular. So make sure they are a nice 90-degree angle. Okay? Again, any questions on any of this, please write it down. So what I want you guys to go ahead and do is to go ahead and pause your video and give this one a shot, and then we'll come back and check it in just a minute. So go ahead and pause your video now. All right, go ahead, take a second and check your work. If for any reason anything ended up wonky, make sure you check each of your steps to make sure that all of your points are in the correct spot. So if our translation is x plus 8 comma y, that means the entire triangle slid 8 to the right and not up and down at all. And then the line y equals 0 is the x-axis, so that means our y values just flipped sign. And in this case, they all went negative since all my original y values were positive. Again, if you have any questions, please write those down, and we will talk to you about them tomorrow. Have a great night, guys. See you later.